Hello.
Hello.
Hi. Can you hear me?
Hi there. Yes, I
Okay.
can hear you.
Good. Yeah. Yeah. So my name is Andre. I work for Google, and we're gonna have a mock interview today. Okay.
Okay.
Uh, what programming language do you use usually?
I use Java.
Okay.
My name's Orkan, by the way.
Okay. Nice to meet you.
I have some interviews coming up in about a month.
So are you gonna
Um,
have? So is it an on-site interview or is it phone screen?
it's gonna be an on-site interview. So just
Okay.
for reference, I have about
Mhm.
4 years of experience. I'm
Mhm.
interviewing for a backend position, and so on-site level interview.
Mhm. Okay. Sounds good.
hmm
Um. Okay. So if you're ready, then we can start.
hmm We can
Okay.
go.
Okay, so maybe for the beginning, just like as a warm up, can you name some of the sorting algorithms you know? Just like
Sure.
main idea, complexity. Yeah, just
Sure.
mhm,
Quick sort, merge
mhm.
sort.
So quick start, can you just
So
quickly explain like main idea and complexity?
sure. Quick sort, we can do it, the sort in place with constant space and n log n time. So what
Mm-hmm.
we do is basically we use divide and conquer
Mm-hmm.
idea, and what we do by what we're trying to do is we take one piece, we generally divide. So we pick an element. So given an array, we pick an element,
Mm-hmm.
and then we try to put all the values smaller than that element
Mm-hmm.
to the left, and
Mm-hmm.
all the values bigger than that element to the right of that value.
Mm-hmm.
And then we do the same thing for the left side and the right side.
So what's the complexity of this operation when we move all values to the left and to the
So
right?
that's going to be on n log n time
So, so specifically of this operation.
of this operation. So um, that's going to be one thing to do it on time. So we're going to do
Okay.
it. One of them is going to be on time, and we're
So
gonna,
can you
because
just
we divide it.
quickly
Yeah.
explain how do you do this in linear time?
So this operation in linear time.
Yes.
Sure. So we there are two methods. There are two ways to do it. So we select this value called pivot value.
Mm-hmm.
There are two approaches. Either we can pick it randomly, any value in the range, or we
Mm-hmm.
could just pick any value, like let's
Yeah.
say the
Okay.
first value.
Mm-hmm.
And what we do, let's say we pick the first value,
Mm-hmm.
and then what we do is that we maintain two pointers,
Mm-hmm.
one to the beginning of the array. I mean, assuming we skip the first one,
Mm-hmm.
uh, start of index one, and one at the end. And what we do is we move the left one to the right until we come across a value that's bigger than the pivot value,
Mm-hmm.
and we move the right pointer to the left and keep moving, I mean,
Mm-hmm.
to the left until we come across a value that's smaller than this pivot value, and then we swap them,
Okay. Okay.
and
Mm-hmm.
we keep doing that.
Okay. Sounds good. So any
And
sorting
at the
algorithms
end,
that
we swap the pivot value with the larger
mm-hmm.
value pointer.
Yeah. Okay. That makes sense. So can you name any sorting algorithm that is slower than n log n?
Um, Slower than n log n.
Yes.
That would be something like bubble search.
Okay. So what's the complexity for bubble sort?
It's O n square or
Okay.
insertion sort. That's
Okay.
O
Do you
n
know any
square.
algorithm that is faster than n log n?
Yes, there's counting sort that
Mm-hmm.
is on, but
Okay.
there is space complexity
Mm-hmm.
that can be large. So what we
Mm-hmm.
do is we maintain an array at the size equal to the largest value,
Mm-hmm.
and then we basically count how many times each value appears, and we increment the value in the corresponding index of the
Yeah.
array, and then we go over the array and um, and then we count each value and then
Yeah.
return like how
Okay.
many times we've seen.
Okay. Makes sense. Okay. Thank you. So yeah, let's move to problem solving then.
hmm
So yeah, I pasted
Okay.
You see the question?
So, given 2D array where true represents water and false represents land, generate a map with the highest possible peak. Rules are the height of any water cell is 0. The height of any land cell cannot differ for more than 1 from any of the neighboring, sharing 1 edge cells. So let me
Yeah,
go
so
over
here's
again.
a sample map, for instance. Yeah, so you have
So
water.
false represents the land.
Yes.
Okay.
The
And
so
I want to understand the height thing for the land. The height of any land cell cannot differ for more than 1 from any of the neighboring. Okay.
Yes. So for instance, you have sample map for the input provided. Yeah. So one is like this is a valid map, and the second one is not valid because you have 2, which is differs more than like 1 from 0. Okay.
So yeah, so the water is always going to be 0. That means true is always going to be 0. And if it's not true, then the neighboring cells, the difference between its neighboring cells has to be at max 1.
Yes.
Right?
Yes.
And does it need to be bigger? It needs to be bigger, right? So that's
so your job is to generate map which follows these rules and which has the highest possible peak. Yeah. Like.
So can you repeat the question again? What am I supposed to return?
So you need basically the height of the height of the highest possible peak. Like
height. Okay, so I'm given
so
this.
If you generate all possible maps which satisfy these rules, and then of all these maps you calculate the height of the highest peak. So you need to return the one that's the maximum. Yeah.
I see. Okay. So I'm given this one, and I need to return if I were generating the highest peak, what would be the height of that?
Yes.
Okay. Sure. Okay. So what should I do if okay, wait a minute. Oh, okay. I see. Okay. So let's see. So I'm gonna be given 2D array. So it's 2D array of true, false values and the neighboring. Okay, so let's see. For example, for this one, so this is gonna be 0 and this is gonna be 0. So this can be at max 1. So when we say neighbor, we look right, left. So we do horizontal or vertical, right? No diagonals.
No diagonals. Yes.
Okay. So this can be 1. This can be 1, and this one we look at the left, right, bottom, top. So this is 1. So this can be 2. Okay. So how about this one? This is 2, this is 0, so this can be only 1. So this cannot be 2. Okay. So let's see. Okay. So this one can be, so this is 1. So but we don't know this one. And what can it be? Okay, so there's 2 sides to this problem. There's this one thing where, okay, so we generate, so there's this question of how do we start, so what we generally will probably need to do, we start assigning values, right? So we know, here's the thing, so we know the truth, right? If it's T, we know it's a 0. So what we can do probably, we can start from the neighbors of these true values, and then we can start setting values for these for these false values neighboring to the true values. But to state it in a more abstract way, we need to start assigning values to the ones that we can, if I may.
Okay. So yeah.
So let's see. But here's the thing. So let's say this is true. Okay, this is true. So this is 0. So how about this one? So we can go ahead and set 1 to this one, right? So there's no need to think about this one. So as long as we are sure that we can start from this one, that is that we should not do this one before this one, we can just set 1, right? So all the values, all the false values next to the true values are going to be 1.
Okay.
For sure.
Yeah, sounds good.
Okay, so we can start from there. So we're gonna set. Okay, so I need some space here to kind of test out some stuff.
Okay.
So I'm gonna be writing here. So let's see the same one. Okay, so let me use additional one. So what I'm going to do is so let me do this. Let me do this and okay. So this is 0 and 0. Okay. And then so neighbor to the 0. This is neighbor 1, 1, 1. Okay. Now which one is going to be next? Now that is an interesting question. Now if it was this one, so this is a false, and so we want to assign, so we can base it, if we know this is 1, this can be at max 2, so it cannot be higher than 2. Okay, so what we can do, what it means also is that any value next to 1 can be at max 2, right? So we're going, so what we can do is just, okay, we start with the zeros and we pick all the elements next to zeros and set them to 1. Okay. Then we pick all the values that are next to 1s and set them to 2. And then so on, like 2 to 3, 3 to 4, and so on. Okay. Now the question is, how can we do this? So I think this looks like, this reminds me of a version of the topological sort, where what we do is we store, so what we do, we go ahead first, pick the initial values, which is going to be the true values, and put them in kind of a queue.
Okay.
And then what we do is we go ahead, maybe not topological sort, but let's brainstorm. So okay, yeah. So we pick the value from the queue. So first we do this. So for this example, we're gonna have 2 values in the queue. Then we pick the value from the queue, and then we assign a value to it. Let's see. What we do, we put in a queue, but we also put in a queue like the previous value as well. Or we put there the value that there should be. We're gonna already know that. So, and then when we pick that, so let's say if we pick the first 2, the trues, what we do is we go ahead and take all the neighbors of that value. We can store the x and y values, the indexes of that coordinate. We can pick all the neighboring ones and then put them into the queue, right? And with the value that they're supposed to be, which is going to be 1 bigger than the current one. And then we just need to maintain like a visited, so that we don't put duplicate times. And when we pick from the queue, we're gonna check, have a visited one? If yes, we're gonna skip that. And then that way we're going to just keep visiting all the values, and we can maintain like a max value integer that's going to store the maximum value, and then we're going to return that max value.
Okay. Yeah, sounds good. So what the algorithm is like? Which famous algorithm is that?
So this is the breadth first.
Yes. Okay. Basically. Correct. Yes. So what's the complexity?
So the complexity is going to be O(n) in time. We're going to visit every element once. N is the total number of elements in the array. And the space complexity is going to be the O(n) again.
Yeah. Okay. Okay, yeah, sounds good. So can you implement the solution then, please?
Yes. So let's go ahead and implement this. So I'm going to implement it over here so that I can take a look. So let's say public static int get max height, let's say. So how am I given the input?
Yeah, just to the array, whatever.
To the array of
Boolean, yes.
Of booleans. Boolean. The let's say
map or whatever.
Map, let's say map.
I'm not sure. Is map a reserved word in Java? I'm not sure actually.
Oh yeah. No, it's I think it's not. It's a map. No, it's fine. Okay. Map is fine.
Template probably.
Yeah. So let's just get rid of the error. That is a bit annoying for me. So what we're going to do is we're going to just iterate over this and set a value. And then first we are going to just wait one moment. I'm turning off notifications on my computer. I'm just getting some. So we are going to we're gonna need so in order to put it into the queue, we probably need to define a separate class. So because inside the queue we're going to set the instance where we're going to store the next value kind of. So let's also define that. So let's do private static class. Let's call it node. That's fine. So that is going to have int next, let's say next value. What else does it need to have? It needs to have the coordinates so that I can pick the next ones. So it's going to have, let's say I think I can do this right. IJ. I think I can. So int IJ, what else do I need to store? So I need the coordinates, I need the next value, and I think that is it, basically. So what I'm going to do is, I will, along the way, I will need a function that is going to give me the neighbors, but I'm going to get to that in a moment. So first, what I'm going to do, I'm going to define this queue that I'm going to use. And to do that, I'm going to, let's see, the queue of nodes. A queue is equal to new. So there's a couple of ways to use this queue, but one of them is a queue interface with a linked list. I like to use this one because this is faster, though not thread safe, but I think that's fine for this example. So, and then we're going, we need a visited one. So we're going to maintain a visited. So that's going to be the same two-dimensional. Visited is going to be equal to new Boolean. So it's going to be of the size map dot length. Then it's going to be map dot map 0 dot length. Then it's going to, I'm going to iterate over for it's going to be I need IJ, so I need I, so I need I is going to be equal to 0. So let's do this. So let's do it. Int age height kind of is gonna be equal to map dot length. Let me assign these to variables so that it's easier to use. I'm gonna use this couple of places. Map 0 dot length, and then so let's use it over here, and it's gonna be age. So I less than age, I plus plus, and then it's gonna be for int j is equal to 0, j less than wj plus plus, and so water is true, right?
Mm-hmm.
So if boolean, if did I do this right? Okay, yeah, I did. If map ij, if this is true, what I'm gonna do is that I'm going to q dot add new node. Okay, so I need to do this where it's gonna create a constructor node. It's gonna be this next value int I int j, and then it's gonna be this this dot next value is equal to next value, this dot I is equal to I, this dot j is equal to j, and so we're going to add next value is going to be 0 for this one, I is going to be I, and j is going to be j. Okay, so we have the initial values over here, and then what we're going to do, we're going to do q dot is empty. So while q is not empty, what we're also going to maintain is int max value, and we're going to set that. There might be edge cases, few, but I don't think that's going to affect the algorithm, so I'm going to consider them at the end.
Okay.
Integer dot min value. So value. So okay, now I'm going to pick the next value. So node next is going to be q dot poll. Okay, so we got the next value. So first thing we're going to check, have we visited this element? So in order to do that, it should be false visited. So we're gonna pick the next dot I, next dot j. Okay, so if this is false, then what we do, we can go ahead and immediately set it. That's the first thing that we're going to do. And then once we do that, what we're going to do is we are going to now set the value. Now, one thing we forgot to do, okay, is there a need to actually maintain the output map, like ones and zeros? Let's see. So if we can do this, I'm gonna go to neighbors. Yes, there is, because I'm gonna, is there a need to maintain that? Because what I'm gonna do is that, so I'm gonna think about that for a moment. What I'm gonna do is I'm gonna take the 0 and go to neighbors, and then I'm going to add all the neighbors, and I'm gonna say next value, and then I'm gonna have them visited already. So I don't think I need to maintain that. So I am not going to maintain the actual map of the ones and zeros. I think we can resolve it without. So because I'm using the visited, I'm going to know. So the downside is that, is there a downside? Not really. So I know the current value. Here's the thing. So I'm gonna have this. So let me note this. So I'm gonna have this method that's going to get me the neighbors. So private, it's going to be the list of coordinates, basically, that is ij. So we can do a list of integer, double integer, private, call it static, get neighbors, int I, So we can pass the map to this. We don't need to pass the map. We can just pass the height value. So int height, int width, then int I, int j. And then this is going to return me all the values that are nearby. And then I'm going to implement this in a minute. So let me first get back to this. So what this is going to be is this is going to do. So now I can get the neighbors. I'm going to do for int neighbor in get neighbors of age w next I next j and then I am going to so for every element I'm going to add this to the queue. I'm going to say q dot add new node. So next value is going to be next dot next value. We could just do a value over there, but that's okay. So this is going to be +1. So this is going to be next I. No, that's not going to be next I. This is going to be, so I'm just going to assume this is the first one. We could define this also as a new, like we could define an additional class for this.
Up here.
Yeah, so I'm just going to use it for now for this one like this. So 0 and 1, that's going to be ij. And so one thing we're going to do also, we're going to do, forgot this one, max value is going to be math dot max of max value and next dot next value. So, okay. And then we're going to basically return the next value over here. And so let's just get to this one quickly. So let's do int let's call it this way, new array list. Okay, and then we are going to, then we're going to return the neighbors. So that's a neighbor. So, so I'm going to do this. So there are a couple of ways to do this. Since we're doing just horizontal and vertical, let's find a dx, int dx is equal to, so 0, let's say 0, -1, and 1, and go this way. dy is going to be -1, 1, and -1, and 0, and 0. 0, k less than 4, k plus plus. We're hard coding 4, which is not a great idea, but still, so we can. So if we decide to change it to that.
Yeah, given that we always have 4, so that's kind of reasonable constant.
Right. I mean, so what if what if they change it so that we cannot count the diagonals as well? So that's like, but for now, I think we can just assume this. So okay, so we're going to check. So one thing we're going to check. So what is it that we need to do? So we not gonna have any true values. So all that we need to do, we need to check that this is inside the bounds. If this is inside the bounds, we're fine. So we're going to do if I plus k. So basically, this is the case. Bigger equal to 0, and I plus k is less than h, and no, what am I doing? Not k, dx, k, dx, k, and then this is gonna be in j plus dyk is gonna be less than w, and the last one is going to be, this one is bigger equal to 0. Okay, if this is the case, what we're going to do name first dot add new int I plus di and j plus j, this one. Okay. Okay, so this looks like it, but let's quickly go over it. So this is going to be true, false. So values can be, so we can set this to either 0. So we can set this to 0 as well. It's going to be max min equal to always 0. So we define the age, map length. So about the input, can I assume that there's going to be like non-empty input, or should I take care of that? So map, yeah. So it's gonna be so if age, so let's do this. If age is equal to 0, or w is equal to 0. Should I return something here?
Yeah, sure.
Something like this.
Yeah, I think so. Looks good.
Okay, so what we do basically is, so we'll create this visited array the q, okay, age and w of size, and then we go over the array, we pick the value that is equal to true, and we add them to the queue. First, ij next value is going to be 0, and I and j. And then, so let me look at that. Okay, so these values we already know. So max value is going to be 0. So while q is not empty, node next we're going to pull that, and then we immediately going to set this as visited to true. We're going to set the max value, the max of current value, and the next value. And we're going to go to the neighbors. We're going to get all the neighbors for this current one, which is going to be the next I, next j, hw. And we're going to add that to the next one. So this is going to be the next one plus 1. neighbor 0, that's going to be what? The I of the next one and the j of the next one. And yeah, so for this one, array list. So it's going to be this 0, 0, minus 1, minus 1, k, 0, k, 4 values. Going to I plus dxk bigger or equal to 0, I plus dxk less than h, j plus dyk is less than w, and the j plus dyk bigger or equal to 0. They are satisfied. That means we're within the bounds, and we're going to add them to the neighbors, and then we're going to return those neighbors.
Okay. So can you run this for the sample that I provided?
Yes. So
what does it
yes. So let's do this. So let's do this. Print line get max new boolean so what is it? True, false, true. So true, false, true, and then it's gonna be false, 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 and then it's going to be false, false, false. Okay. What did I do? Incompatible types. Do not be converted to a list. This is a list.
Well, I guess here it should be like just.
Yes. Should be one.
Oh yeah, cool.
Okay.
Okay, looks good. So the only question I have is with visited. So basically my question is, do we
need to visit it?
So basically, when you add new things to the queue, it seems like you always add all the neighbors, even if they're not visited. So
yeah, we could check that. So we could check that and not add them.
So probably it should be slightly more optimal. Just basically, if some cell is already visited, we don't really need to add it to queue. I mean, it's still it's gonna work fine, but just
but we can do that as well. Let me actually quickly go ahead and add them. So we're gonna do this one. So we're gonna add it only if it's not visited. So the question would be, do I need this one though? Well, we can change it to this one. Do I need at any moment? So we're gonna add, and then we can technically add it over here and then set the visited as true. And then there's never going to be another case where there's like, so we can carry this over here as well. So we can carry this over here. So let me try this. So we can carry this over here. We need to also carry this one, add this one. I don't know if I'm doing a good thing. let's try and do optimization. So we're gonna true, and we just get rid of this one altogether.
Yeah.
And then like we get rid of this.
You just make sure you use the right coordinates when you set visited.
Right. Yeah. Yes, I am going to. So what I'm going to do is take this one. Oops. And set this one.
Yeah. Okay.
So 1.
Looks good. Yeah, you can try to run it just to see. Yay. Cool. Okay. Yeah. Cool. So additional question: what if? So basically, the problem is the same, but we add also secondary kind of optimization criteria. We also want to maximize the amount. So basically, let's say I pass it to the yeah. So basically, let's define every land point with zero height, height of 0, sorry, like a beach. So we want to still have the highest peak possible, but we also want to maximize the amount of beaches.
So what if we want to add secondary optimization goal, maximize the amount of beaches, land tiles with the height of 0, land tiles with the height of 0 while keeping max peak height. Okay. What would be the beach, right? Next to the water?
Not necessarily. Any land tile that is the height of 0.
Any land of height 0. Okay.
So basically, to rephrase, so when you generate maps with the highest peak, it might be that you can generate many maps, all sharing the same height of the maximum peak. And then of all these kind of maps, I want you to pick the one where we have the maximum amount of beaches, right?
Maximum number of beaches?
Well, maximum number of tiles, yes, with height 0.
Okay. So the idea is that, like, next to the water, I could have either 0, like land next to the water could be either 0 or 1, right?
Yes.
So if it's a 0, then that's a beach.
Yes.
Right. We want to have
that. It doesn't have to be near the water. Yeah.
You're right. Sure. Like, okay, it does not meet it. We can set all of them as 0, and still that's going to be valid.
Yeah.
Right.
So yeah,
all of them is going to be beaches.
The only problem is that you need to also maximize the height of the highest peak. Yeah.
Exactly. We want to have the maximum height at the same time.
Yeah.
So the idea is, so what is the question?
How would you do that?
How would we do that?
Yeah.
Okay.
How would you change your algorithm to do that?
So how can we change in order to maximize like my number of beaches? Okay. Here's the thing. Let's say we generate this, right? And then what we could do is we could, like, this is one way, I'm just brainstorming. We could try to go back and like set some of the ones to 0, right? That would be one approach. But I need to make sure that I'm maintaining the rules. So in order to do that, there's going to be so when I'm picking the maximum one, I'm just picking the one values next to the water and adding 1 to it. So in that way, basically what I'm trying to do is I'm trying to set the highest value to the lands, right? So land values maintain the highest value possible of any combination, right? So
yeah, so maybe I pasted like a small example which might help you, like with your thinking.
What we could do. So let's say we generate. So one thing I'm thinking is that okay, we generate this. So we did this thing. How maybe we can use the result of this in order to arrive at that one. So what if like we have
for the example that I pasted, for the example that I added, what do you think is the answer, basically?
What's the answer to that? So this is going to be so this needs to be 1, and then this is going to be 2. So maximum value is going to be 2. So this is 2, and this is 1, and this is 1. The rest of them can be 0.
Yeah. Okay.
Right. These 4 can be 0.
Yeah. So how can we achieve this?
So what we could do again, we could so the number of ways. So we could just let's say we generate all of them, right? So we generate what we just did, and then let's say the value is 3. The maximum height is 3. Okay, we could have number of the 3s, like number of 3s in our map. We just pick one, and we try to maintain that. The way we maintain that is we start from that one and make sure all of the values next to that one are 1 smaller, and then values next to that one are 1 smaller until we reach 0.
Okay.
And any other value can be 0 completely.
Yeah. Okay. Sounds good.
So all the values. So this is just we need to maintain that, make sure that all the neighbors contain the 1 smaller value, not 2. So the difference is going to be. So we can just maintain 1 peak and keep reducing the neighbors of that until we reach 0.
Yeah. So okay. So let's say we handle this peak. So what do we do next? So we picked 1 peak and did the procedure that you just described. What do we do next?
What we do is in the meantime, we take notes of all the values that we maintained, and then we iterate over the map again. And if for any value that's not one of those values, we just set that value to 0.
Yeah. Okay.
And then if we need to return number of beaches, for example, like we just do something like we count them. But one question becomes like, okay, if we need to, how do we pick the peak to maximize?
So that's
Yeah. So how could we just make sure that we're picking the peak that is so that we maximize? Okay, so what is difference? So difference is going to be, let's say for this case over here, it's going to be, the peak is going to be in the corner, right? So all we need is just these values next to it, and they can be 1 and 1, and the rest of them can be 0. Well, we don't have a lot of choice over here, but basically what I'm trying to arrive at, by picking a value that's next to the corner, we are basically just reducing number of the heights, because like to the top of that or to the right of that value, there's not going to be any other value. So we could pick one way, maybe we could pick a height that is toward the corner, maximum toward the corner. Does that make sense? So what would be another one?
Just to clarify, what is like so for each peak we know how to calculate the maximum amount of beaches, right?
Yes.
So what like, and then we have fixed number of peaks with the maximum height. So what's the problem?
So what we could do, we could just iterate over each of them.
Yes.
And like try each one of them and see like how many beaches we get with each of them. Okay. And then like so I thought maybe there's like a explicit quick way to know.
Well, there might be, but I'm not. I'm not sure I can think of anything straight away. Yeah. Okay. That actually sounds like a correct solution. Yeah. So basically, we go through all like highest peaks, and then we kind of go backwards. We try to
so we select that as the only peak. Yes.
Okay. Yeah. Sounds good. Do you have any questions?
Not much. Just a couple of things. Like, what do you think in terms of speed? Like, was it in a good case? Was it expected to implement, let's say, just this solution that we talked about, like the last one? So
I would
number of beaches.
Expect that, yes. So the one thing which is a bit different here is that, well, usually on the, like at least in Google and on the interview, you don't really run the program that you wrote. Yes, you usually just write the code, and then you do like a mental compilation or whatever. Yeah. So probably that makes it a bit easier because, well, you can cut some corners, and so I'm not quite sure how to adjust that. So probably it will take you like a bit, like it will be a bit faster to implement things during the interview. I would expect it because. Yeah. But you actually, I think you did like a reasonable pace. So yeah, I would expect this solution. Yeah.
So I would in order to implement the other one, the next one.
Yeah. So that's I don't expect anyone to fit the second problem in the 45-minute interview.
Oh, well, that was basically what I was asking. So within the 45 minutes, like for what would you expect? How much?
Yeah, so basically my expectation would be implement the first solution and describe the algorithm for the second.
I see.
I think that's reasonable to expect, yes, from a reasonable candidate.
Okay. Basically. So what do you think about the in terms of coding? So is it clean, or is it like something can be improved?
Well, so the thing is, I'm not really that familiar with Java, so I'm not always know like the best practices in Java. But yeah, overall it looks pretty reasonable, yeah. And
Okay. And I mean, I don't have much questions. Like, do any other feedback that comes to mind?
Yeah, well, I guess I'm gonna steal the feedback after the interview. So
sure.
You'll do the same. Yeah.
Okay.
So
maybe one thing I can ask you. That's for instance, like if anything that comes to mind, like what would you advise I could work on to improve in any way? Like I always like to improve. So like what would be like one advice?
Well, based on my experience, nothing particularly. There's. I think things were quite reasonable, so nothing I can kind of pinpoint to and say, well, it seems like here you're not quite as comfortable as I would expect. No, I guess.
Okay.
But we only covered like certain algorithms, right? So maybe.
Yeah, sure. I mean, basically that's sure. I mean, that's from what you know. I meant. Like anything you like noted that could be improved. Anyways, one thing, maybe last thing I could ask you. So like for a person that is like have that 4 years, what kind of other than the regular coding, like this one coding interviews, would be expected? Like maybe not too hard of a system design, but any kind of other like caliber of questions that are being asked?
Well, not
Do you
the
have any
final.
idea?
Yeah, I guess usually it's like 1 system design and 3 or 4 coding interviews.
Right.
And yeah.
And what do you think about, so we just have like 5 more minutes. I'm just counting toward the end of the hour. That's why I'm curious about a couple of things about the logo, maybe specifically. So like, let's say I go to an interview, and let's say there's going to be, I think, 4 technical interviews and 1 behavioral interview. So from those technical, so let's focus on technical ones. Like, how many? Let me ask it the other way. How much mistake, or how bad could I do and still get a good enough feedback to get an offer? Like, well, do you have any idea on that?
Not quite. Yeah. So basically, how it happens like that. Yeah. So somebody interviews you, then they write feedback, and they say, well, I have these questions that they answered this to the thing, and maybe they point like, okay, here candidate like come up with a great algorithm quickly, great, or maybe it required a lot of hints for him for them to achieve that. So,
sure.
And then you have a hiring committee. They look through all these feedbacks and they kind of think, okay, what do we think? Is it a reasonable candidate? So obviously there is no kind of easy way of achieving the decision of hire or no hire. Otherwise, they wouldn't spend so much effort and time of the highly paid individuals to which goes into hiring people. So if there were some like easy way of saying, okay, can we calculate some number, and if it's more than 10, then we hire. If it doesn't, then no hire. Well, obviously, if they could do something like that, they would much rather do that.
Yeah, they'd probably do that.
Spending hours and hours of engineering time just to So I guess.
What would be I see your point, and that totally makes sense. Like, is there like, if there was one quality you think that is like probably most important, what would that be?
Well, again,
I mean, I'm asking crazy questions.
Being able to solve the problems and write the code.
Right. That's problem solving, right? Because they do behavioral interviews, and that's like the asking person, like, well, describe a moment when you had this. I think that's more of a, like, they want to understand like your business ethics, like how you work with other people and stuff like that. So I'm just wondering, like, is that how important that is during the evaluation, and how much
I'm not
that plays
into with behavioral interviews. I'm not that familiar. So
I see.
I never did them, and I guess that they were introduced just not very long time ago. So I'm not even sure.
They might have been,
Yeah,
I was told by a recruiter that I'm gonna have that one.
Yeah, so unfortunately, I cannot tell you much about it. But that's non-technical, right? It's more like
it's not like technical. It's just
do you really want to work for Google, or do you really?
No, it's more of a leadership thing, I think. Like describe a time when you had a conflict, kind of or you had a hardship in a certain project. How did you deal with that kind of stuff?
Right.
Yeah, I mean, those are the things, but other than that, thank you for your time. This was interesting. Thanks for answering my questions.
Yeah, no worries. Yeah. Okay, have a good one.
Yep. All right. Thank you. You too.